the day chemistry stopped being harmless. For centuries, chemistry felt safe, curious, contained. Then one reaction crossed a line, and the world never looked at matter the same way again. For most of its history, chemistry existed at a human scale. It unfolded in glassware and notebooks, guided by observation rather than force. Early chemists mixed substances carefully, watched colors change, noted precipitates forming, and learned slowly through repetition. Reactions were limited by patience, by available materials, and by the natural pace of matter itself. Chemistry explained the world, but it rarely threatened to overpower it. To understand why this moment matters today, we have to return to a time when chemistry was mostly observational. Substances were combined to see what would happen, not to make something happen faster, stronger, or bigger than nature intended. Experiments were small enough that failure remained local. If something went wrong, it affected a bench, a room, or at most a building. Knowledge advanced cautiously, and consequences were visible almost immediately. That balance created an illusion of harmlessness. Everything changed when scientists realized reactions could be pushed beyond natural limits. Not just observed, but forced. Pressure could be increased far beyond atmospheric norms. Heat could be intensified and sustained. Catalysts could be introduced to bypass natural constraints. Chemistry no longer waited for conditions to arise. It created them. In doing so, it stepped out of nature's rhythm and began setting its own. At first, this shift felt like undeniable progress. Reactions that once took hours became instant. Processes that required rare conditions could be reproduced anywhere. Control replaced patience, and efficiency replaced restraint. Chemistry became predictable, reliable, and scalable. Entire fields accelerated almost overnight, and the success validated the approach. When results improve and repeat, skepticism fades quickly. But hidden inside the success was a deeper transformation. Chemistry was no longer just revealing how matter behaves under natural circumstances. It was deciding how matter should behave under engineered ones. Reactions were optimized for output, not understanding. They were replicated faster than their broader implications could be studied. What worked cleanly in isolation was suddenly deployed everywhere at once. This was the first real fracture in the idea of harmless chemistry, a moment when curiosity quietly gave way to power, and when the question shifted from what happens to how far can this go. The reaction itself did nothing wrong. It behaved exactly as designed. The danger emerged from scale, speed, and confidence combined. As the reaction spread, its influence escaped the laboratory entirely. What had once been handled by a small number of specialists became embedded in systems far larger than any experiment. Factories adopted it for consistency. Industries relied on it for efficiency. Supply chains reorganized around it. Chemistry moved from controlled environments into infrastructure, where repetition replaced reflection. At first, nothing seemed wrong. Products improved. Processes stabilized. Variability decreased. The reaction delivered precisely what it promised, and that success discouraged hesitation. When chemistry works flawlessly, it rarely invites caution. Familiarity bred trust, and trust encouraged expansion. But scale changes behavior. A reaction that is harmless in small quantities behaves differently when repeated endlessly. Heat accumulates rather than dissipates. Waste compounds rather than disappears. Byproducts interact with each other in ways no single experiment reveals. Chemistry does not reset between uses. It carries history forward. Scientists began noticing subtle shifts. Reactions started interfering with one another. Outputs drifted slightly from expected norms. Systems required tighter controls to maintain the same results. The chemistry itself remained correct, but the context in which it operated had changed. What was once isolated had become interconnected. This is where early conflict emerged. The reaction was now too useful to abandon, yet increasingly difficult to fully control. Adjustments were introduced. Safeguards layered on top of safeguards. Monitoring systems expanded, but each solution introduced new complexity, and complexity reduced transparency. Understanding lagged behind implementation. What made this moment especially dangerous was its invisibility. The reaction did not announce its risks with dramatic failures. There were no immediate catastrophes to force reevaluation. Instead, there was gradual change. Chemistry doing exactly what was told, while the system surrounding it adapted in ways no one fully mapped. Harmlessness did not disappear suddenly. It eroded slowly, reaction by reaction, as chemistry's reach extended beyond any single discipline's ability to anticipate long-term effects. What once felt contained became diffuse, embedded, and difficult to trace. The conflict deepened when consequences began appearing far from their source. Effects surfaced in environments never intended to host a reaction. Materials behaved differently over time. Biological systems encountered chemical conditions they had never evolved to handle. The distance between cause and effect widened, obscuring accountability. What made this phase so unsettling was delay. Years passed between action and outcome. By the time patterns became visible, the reaction had already become indispensable. Entire systems depended on it. Removing it meant dismantling structures built entirely around its presence. Scientists traced the changes back to the same origin, not to mistake, but to success amplified too far. The reaction had been optimized for speed and output, not longevity or interaction. Chemistry had been asked to perform one task perfectly, and it had done so without regard for everything surrounding that task. Attempts to contain the fallout revealed another layer of difficulty. The reaction no longer existed alone. It had spawned dependencies. Secondary chemistry relied on it. Economic systems adjusted to its reliability. Even regulations struggled to keep pace with its integration. Chemistry had outrun the frameworks meant to guide it. This accumulation carried emotional weight because the danger was no longer abstract. Data confirmed what intuition had begun to suspect. Chemistry had crossed from tool to force. It was no longer responding to conditions. It was shaping them. The world faced a paradox. The reaction that unlocked progress was now limiting choice. Chemistry, indifferent to regret or intention, continued responding to scale exactly as the laws of matter demanded. It did not misbehave. It simply obeyed. The climax arrived with a realization that could no longer be avoided. Chemistry had not become dangerous because it was misused. It became dangerous because it was trusted too completely. What once felt harmless was never neutral. Every reaction carried consequences that required time to surface. By the time they did, chemistry was no longer something society could step away from. It had woven itself into daily life, industry, and survival. This moment reshaped how chemistry was understood, not as isolated reactions, but as systems with momentum. Once set in motion, those systems continued forward, reshaping conditions long after original intentions faded. Control, it turned out, was always temporary. The resolution lies in awareness rather than fear. Chemistry itself did not betray humanity. It followed its rules faithfully. The error was assuming those rules stopped at the laboratory door. Scale transformed harmless reactions into defining forces. Today, chemistry is approached differently because of this turning point. Safeguards matter. Context matters. Long-term impact matters. Not because chemistry is malicious, but because it is powerful beyond instinct. This story is not a warning to stop exploring. It is a reminder to slow down before scale locks choices in place. To ask not only what a reaction does, but what it becomes when repeated everywhere. Subscribe to join the journey.